No, we're getting there. We're getting there. Ooh, nice try, buddy.
Okay, I know what you're thinking. Chet, you haven't posted all semester. We missed you. Your videos are so funny. And you're right. My videos are really funny. And I haven't posted all semester. The reason being, I just been locked in. I started working. I'm taking a class that's kind of winning right now. That's kind of what this video is about. It's about that class. We have a final project where we're programming and kind of making an autonomous robot car. Is it clickbait to say it's a car when it's a foot long? It's not an actual car. I want to point that out. I don't know if the thumbnail gave it away. But next time you see me, I'll go over a timeline and what's actually happening with this project. So see you then. Should I do a transition? Would that be cool? I said next time you saw me, I'd be going over the timeline and the overall plan of the project. So here I am. It's split up into 3 parts, or 3 separate labs. It's part A, part B, and part C. Lab A, we demoed it on the week of the 7th, so I think it was the 9th that we actually demoed it on.
Bro.
Yeah. Why is the left turn so bad? Left turn so bad.
Left turn so bad.
Part B, that is still due on the 16th for a hard deadline. And then part C is the qualifiers and the actual race. By then, we're going to hopefully have a completely finished bot. That is due on the 21st. That is due on the 21st, but it's spread out across the entire week of the 21st. So we really only have another, 8-9 days before we have to be like set in stone. We are done with this little car. Now to elaborate on what our team is doing for the project, as I said, we interface sensors. I don't know if I mentioned which ones. We're using IR, LiDAR, ultrasonic for our main sensors. I don't think we're gonna use ultrasonic, because that's lame. Like, why would we use ultrasonic when we have LiDAR? I don't think I actually showed what the cart looks like. I might have even put like a little video, but I can grab it. It's in my room. Sorry, our little tote is a mess that holds the car. It has a bunch of trash in it from our microcontrollers and sensors and stuff. It's kind of focusing. As you can see, it's a work in progress. There's some sensors. Those are all IR. We do have to change the mounting. Now what we're actually doing with all those sensors in that car is we're grabbing the sensor values and we're putting it into some sort of algorithm that dictates how fast we should move and how much we should turn with the front servo. There are multiple ways to do this, and we're going to try doing it multiple different ways and just see which one works better. But yeah, that sounds great. Let's get coding and grinding, shall we? Okay, I think the PID controller is about done. We're about to throw it on the robot to test it. This is the robot over here. Also, this is Clock, that's Jacob. Yo, it's Jet from the future. Here at this point, you can see that the car is reacting to sensor inputs. It's nowhere close to being done. We initially had this issue where it was hard to get the car to turn dramatically. The way that we approached our issue with the steering is by implementing differential steering on our back two motors. To put it simply, differential steering is just having a difference in the velocities of your motors to account for the difference in radiuses on turns. This would allow our turns to be a little bit more reactive and a little tighter when needed, though it didn't come without issues. That's all. Yeah, that one goes way much lower. It's Wednesday morning. We're back on the grind. I think it's April 16th. Yesterday we did our early checkout, a day early. Shout out to my partners who wrote a quick bang bang code that just reacts all the conditionals. It's great. That's a perfect controller to have too. We might even use it in competition, but I'm still gonna try to tune the PID controller, see if we can get it working. So that's what I'm doing today. And here comes the trial and error of tuning the PID controller. It was a constant loop of putting the car on the ground, watching how it turned, and then bringing it back to the computer and tweaking a few numbers. I also went ahead and calibrated the IR sensors because I realized we never did that, and it's kind of important.
You're saying while it's turning, it turns the other way when backing up. Or does it just back up and go along the same route?
It is now Monday, April 21st, and tomorrow, the 22nd, is our qualifying race. I'm not sure what time it's at. I think it's sometime in the afternoon. Hopefully, I have class literally from 9:30 to 3:30, and then I have more class after that. Come to think of it, I don't know when I'm attending the race. This afternoon is probably going to be the last time that I get to work on it. All that's really left is tuning. If you saw in my recent time lapses and stuff, I probably voiced it over. I changed the controller completely. My original design was just a little too complex for how simple the race actually is. That being said, next time you see me, this afternoon, hopefully, is going to be the last time we're tuning the robot. By the 21st, the robot began looking much better. This wasn't just because of tuning to the PID controller, but also just a revamping of it, because I realized I was writing way too much code. But with this redesign, it just seemed like the robot was much more reactive to turns and also had better turns in general. We had an issue with the power cord breaking off of the board, and we had to resolder it. But other than that, our main concern became tuning our robots into its final stage. Now on the 22nd and the hours leading up to the race, we were able to have test runs on the track that we would be using for the qualifying race. This would allow us to find solutions to getting stuck and reversing out, allow us to hone in our speed because we weren't yet sure on what speed we wanted to go on the track, and it allowed us to figure out if we could actually hit the snaky turns that they made available for us.
Right here. I don't know. There we go, there we go. Good, good. Make the left, make the left. Yes, yes, bro. Oh, hit once. Brother, I feel like the battery gonna die the way it's moving. Nice and chill.
Now you just saw our first race for the qualifying rounds, and I think it was our best one, so I'm glad that we recorded that one all the way through. With a score of 25 checkpoints, we secured a 4th place finish out of, I want to say 9 or 10 teams, maybe 11 teams. I guess I don't really know how many teams there are. And my group was really happy with this 4th place finish because it ensured that we get 100 on the lab. Real ones know the qualifying rounds were where it's at, so shout out to the 4th place finish. Had a lot of fun. The entire group did. It was a really cool project, probably my favorite class that I've taken at UT. Another video will be posted later this summer, hopefully in a few weeks, on my experience in the class and what I rate it, and another rank engineering video. I think that's all, so I can go ahead and show some clips of the final races right now, and y'all can be on your way. So, made it this far, I hope you enjoyed, and as always, stay curious.
what? It doesn't matter what place you get unless it's first, because then you get bonus points. Because at the end of the day, it's the night. It's night.